So types of faults where you have subduction zones. Subduction zones occur when you have converging plates, an oceanic and a continental. Causing the oceanic to sink underneath the continental creates a mountain chain, but in particular it creates volcanoes. So at the volcano, it's a place by definition where molten rock and gases exit the planet's surface. We have two different words that often get tossed around with referring to the molten rock: magma and lava. To distinguish between them really quickly, magma is the molten or partially molten rock that's below the Earth's surface. Lava is magma, but specifically magma that has erupted and reached the surface of the Earth. So why exactly does a volcano erupt? So the way a volcano erupts is you have dissolved gases that are under high pressure inside of this fluid. Now as the magma begins to rise higher and higher and higher through this chamber, the gases will begin to become under less pressure, and that decrease in pressure allows the gases to come out of the fluid. If the process happens too quickly and the magma continues to rise and rise and rise, it will eventually erupt. Sometimes when it erupts, the magma slowly leaks out of the volcano and turns into lava, and it's nothing too serious. This happens quite a bit on the volcano in Hawaii. It's nothing too intense. Other times, this goes absolutely nuts and it blows the entire piece of the volcano away. Goodbye. To give you an example of this, Mount St. Helens in the state of Washington is a perfect example. On the image on the left, you'll see Mount St. Helens prior to the eruption. The image on the right, you'll see Mount St. Helens after the eruption. That red dotted line used to be the summit of Mount St. Helens. It's a little bit hard to tell because of the snow, but this land here, this is all covered in snow, and it's a nice big crater right in the middle of that volcano. So when the volcano erupts, we obviously get lava flows, and the lava flow is controlled by three things. I apologize. The lava's viscosity is controlled by three things. To quickly summarize what exactly is viscosity, viscosity is nothing more than how thick the lava is. It's controlled by temperature, composition, and gas content. The cooler it is, the thicker it is. The more silica that is found in the rock composition, the thicker it is. And the gas content, meaning if there's more gas bubbles, it's actually less thick. If there's less gas bubbles, then it's more thick. We get pyroclastic debris. These are rock fragments that are ejected from the volcano. We classify them in 4 different levels. Rock fragments are the big ones. Then we have lapilli, which are little stones. There's also volcanic ash and volcanic dust. The only difference between ash, dust, stones, and the rock fragments are their sizes. The gases produced in the volcano will cause a bubble-like feature to appear on the rocks. It's vesicular in nature, it's a vesicular texture, and it looks something like this.